Friends, welcome back to a new session. So in this video we are discussing about some things about integration. So we know that in the previous video we learned that more and more integration questions and its solution and some basic properties also. But today we are learning about what is the importance of the integration. There's an important things that are existing, that is we are talking about integration by substitution. So some integration question which cannot be solved by directly by any solving methods, so we can use another method which is a substitution method. By substituting one function by another function, then we get a proper value from there. So this is a typical thing in mathematics, so which is very important when sometimes solving an integration question. So now we are learning about a new integration question, so it will be helpful you at sometimes. So let's check it out. That is integral of 1 divided by a square plus x square with a dx. So which is equal to integral of 1 divided by x square plus a square dx. And note here that we can use the main things, that is substitution. So by substitution it will become, that is x square plus a square here existing in the denominator. So we can substitute that, put x is equal to a tan theta here. By substituting these things in the given equation, then we get a proper solution from there by simplifying that equations there. But before substituting this value into the given equation, we want to do that, find dx divided by d theta here, that is the derivative of x with respect to theta. So it will become a into derivative of tan theta, which is equal to sec square theta, and we get a solution as, that is the value for dx which is equal to a sec square theta into d theta here. So by substituting these things in the given formula, then we get a solution as integral of 1 divided by, put x is equal to a tan theta. It means that a square tan square theta here, then plus a square with the value of dx, the value for dx which is equal to a sec square theta, that is into a sec square theta d theta here. So in the next step it will become integral of 1 divided by, in the denominator, a square into tan square theta plus a square. So here a square are common in both the terms, so we can take it the a square in outward, then we get a solution as a square into tan square theta plus 1, with the term in the numerator is a into sec square theta, a into sec square theta d theta, and the a square and a will be cancelling, and there is a constant 1 by a is existing. In the next step it will become 1 by a into integral of sec square theta d theta, sec square theta d theta, divided by using the trigonometrical identity, that is sec square theta minus tan square theta, which is equal to 1. Therefore the value for sec square theta here, which is equal to 1 plus tan square theta. Therefore the value for tan square theta plus 1, which is equal to sec square theta, by using the trigonometrical identity, then we get a solution as here sec square theta d theta into d theta. So note here that the numerator and the denominator are same. Therefore the solution which is equal to 1 by a into integral of 1 d theta. So the solution to become 1 by a into theta, or theta by a here. So note here that we put x is equal to a tan theta here, that is the function is replaced by another function, that is x is equal to a tan theta. So our substitution is x is equal to a tan theta here, which means that the value for theta which is equal to tan theta, which is equal to, by taking the a from RHS to LHS, then we get a solution as x divided by a, then theta is equal to tan inverse of x by a here. So by substituting the value of theta which in the given formula, final formula, then we get a solution as tan inverse of x by a whole divided by a. So finally the solution for integral of 1 divided by x square plus a square dx, which is equal to 1 by a into tan inverse of x by a. So this is a solution for this integration question. Note here that we used the substitution method. So sometimes in the integration question, the substitution method is very important, and it will be helpful to reduce the complexity of the given equation or the formula to find a proper solutions. So in mathematics, in every and each theorems, there is an importance is existing. That is, I mean that we learned that about how to find integral of 1 divided by x square plus a square dx, which is equal to 1 divided by a into tan inverse of x by a plus c also. So it is an indefinite integral, so put a plus c here. So in this session we learn an equation and its solution, but there is a question is existing. It is that what is the uses of this equation here and why we learn these things. So let's check it out by checking some few questions based on these things. So here I write a question as integral of 3x square divided by x raised to 6 plus 1 dx. So let's find the solution for this question by using the given formula which is derived in the previous part. So let's check it out the solution of this question. So it will become, note here that there is a complexity is arriving, that is numerator containing a term and a denominator also contain a function. So there is two function, the numerator and denominator is existing. So we can use, that is we want to convert these things into the our given formula as the form of 1 divided by integral of 1 divided by x square plus a square dx. But how we want to do that? Put t is equal to x cube here. So we now when taking t is equal to x cube, then after we want to do that finding the derivative of the substitution, that is dt divided by dx, which is equal to 3x square. We now the derivative of d by dx of x raised to n, which is equal to n into x raised to n minus 1. So by using this formula we can write the what is the derivative of x cube here, which is equal to 3x square. Then the value for dx, which is equal to dt divided by 3x square here. Then in the next step it will become integral of 3x square in the numerator, and in the denominator note here that we can write x raised to 6 plus 1 here, and we can write x raised to 6 as x cube whole square plus 1 dx here. So the solution to become integral of numerator contain 3x square divided by, we now that is x cube which is equal to t, that is x cube which is equal to t. Here x cube square is existing, that is t square plus 1. Then putting dx, that is the value for dx which is equal to dt divided by 3x square, dt divided by 3x square, and 3x square and 3x square will be cancelling, and we get a solution as integral of 1 divided by t square plus 1 dt. So note here that this equation is also similar to the given derived formula, that is integral of 1 divided by x square a square dx, which is equal to 1 divided by a into tan inverse of x by a plus c here. So we can use this formula here, that is we get a solution as, note here, 1 by a, that is the value for a which is equal to 1 here, that is t square plus 1 square, a is equal to 1, that is 1 divided by a which is equal to 1 divided by 1 into tan inverse of x by a. Note here that the value of x which is equal to t here, that is t divided by the value for a which is equal to 1 plus c also. Then we get a solution as tan inverse of t plus c. When writing the final solution we want to change the value for t or substitute the value for t here, that is tan inverse of, we taken t as t is equal to x cube, that is tan inverse of x cube plus c is the final solution of the given integration question, integral of 3x square divided by x raised to 6 plus 1 dx here. So in this video we learned that what is the importance of substitution method in when integration question is arriving. Sometimes some formulas in integration is also very useful to identifying the solution for integration questions. So we will be back with more and more questions and solution based on integration and its property and more. So we can learn more things about these integration property in the next session, in the next video. So don't forget to subscribe our channel for more informational videos. So stay tuned with us.